Hey everyone, this video is on exponential growth and decay. When we're talking about exponential growth and decay, both of these are going to use the same exponential equation. That equation is y equals a times b to the x power. Now a and b don't have any special meaning, it's just letters that we use to represent amounts. In this case, a is always going to be your initial amount. That's however much you are beginning with. So that's how much you have when your time is equal to 0. The next thing is the b. The b is either your growth or your decay factor. The program also tends to call it the multiplicative rate of change. So if you ever see them asking for the multiplicative rate of change, they're asking for this b. And then the x, that's normally the time. So in the initial amount, the x would be 0. If they want half an hour, it could be a half, an hour, 1. This number can be whatever you want it to be. Now, when we're talking about exponential growth and decay, it's still going to fit into this equation, but now it's going to look a little bit different. In exponential growth, we take whatever the growth rate is that they give us, but we have to add the 1 to it. The reason why we add the 1 is the 1 represents the original amount. Or in percentages, it would be 100%. It's the whole amount. And then it's going to be growing by some amount after that. So if they tell me that something is growing or has a growth rate of 20%, 20% as a decimal is the same as 2/10. And then we would add it to the 1, so 1 plus 2/10, and that's going to give us a growth rate of 1.2. That's why in exponential growth, a lot of times you'll see improper fractions because they won't write it as a decimal, but they may then write it instead as a fraction. So they may give you a growth rate of something like 5/4. That means if I turn it into a mixed number, it's 1 1/4, or 1.25, so it's actually growing at a rate of 25%. So you know it's exponential growth anytime this number, anytime the b, because remember it's a times b to the x, anytime the b is greater than 1, that's how you know that it's an exponential growth. An exponential decay, if you notice instead of a plus, it's a minus. Now what's confusing is there's a growth rate and a decay rate. This equation is written in terms of growth. So what that means is if they tell you it's decaying by 20%, we turn that into our 0.2 again. But that means in our equation, it would be y equals a 1 minus 0.2%, or 0.2x, meaning in the equation, it's actually going to be a 0.8, because this is factoring in how much is remaining. So this is remaining, and this one is how much it's losing. So you have to be careful if they ask you the growth rate is how much remains. If it asks you for how much the decay is, well, we have to remember that it was subtracted from 1. So you're going to need to take this number, 1 minus 0.8, and that will give you how much it's actually decaying by. So we have to be careful with that. Are they asking for growth or are they asking for decay? Now, just like exponential growth, the b value is greater than 1, and exponential decay, the b value has to be less than 1. So you know it's decaying if the number with the exponent is less than 1. So if we take a look here, here's two different equations. If we look at this one, first thing I want to know is it is a growth or is it a decay? So if I look here, this says 1.02. 1.02 is bigger than 1. So that means this is a growth problem. It's something that is growing. Now when it says find the initial amount is this amount right here. That's how much it's starting with, so that is 12. And now the growth rate, remember it's not 1.02 because growth is normally 1 plus whatever it is. So if I know this is 1.02, I'm going to do 1 minus 1.02, and that's going to give us a growth rate of 0.02 or 2%. Now let's go look at this problem. This problem, I want to know first, is it a growth or is it a decay? So if I look right here, I see that's 3/4. That is a fraction, and 3/4 is less than 1, so that means this is a decay problem. So now I know my initial. I'm starting with 1,500. And now this is where we have to be careful. The number in this equation is actually the growth factor. So every time it changes, it keeps 3/4 of itself, or 0.75. So if I want to know how much it's decaying by, I need to subtract that from 1. And that means the decay factor is 0.25 or 1/4. So you have to make sure you're paying attention to the difference between the two. Now the last thing that this lesson asks you to do is to actually write the exponential function based on a table or if they give you a graph. So whenever I write an exponential function, I'm going to start by writing my form. This reminds me that A is the initial and B is the multiplicative rate of change, or our growth or our decay. So anytime you want to find the initial, that is always when your x is equal to 0. So in this problem, I already know I'm going to start with y equals 0.5 times. And now we have to figure out our growth rate. Normally, when it's multiplying, that means it's this number times a constant to get to this one. And then it's this number times a constant to get to this one. Since we don't know what this constant is, we have to do everything in reverse. Instead of multiplying this by the constant to get the 0.02, now we're going to go backwards and we're actually going to divide the second number by the first one. So everything has to go in reverse. And if this was a graph, if I had a graph that looked like this, we'd do the same thing. We would find the 2 points, and we would just take this one and divide it by the one before it to find the answer. So if I do that here, I'm going to take my second one and get 0.1 or 1/10 and divide it by 0.5. Then I'm going to grab a calculator, which is right here, and I'm going to do 0.1 divided by 0.5, and that tells me that my growth rate is 0.2. If I want to check it, it should be the same every time if it's exponential. I'll do 0.2 or 2/100 divided by 1/10. and that still gives me 0.2. So that means in my equation right here, my growth factor is 0.2 to the x power, and that would be my equation. If I want to test it, I'm going to test this point right here. Because if this is on this equation, it should be true. So what this is telling me is that if I have 0.5 times 0.2 to the negative 2 power, if we're correct, it should equal 12.5. So I'm going to put in my calculator 0.2 to the power of negative 2. Multiply that by 0.5, and we get the correct answer of 12.5. So that way I know that my equation is correct, and I know that that point falls on the line. I hope that this video has helped you with exponential growth and decay. I look forward to seeing you on the next video.